Okay, so this section is on solving logarithmic equations. The last one was on exponential. This one we're gonna teach you how to solve logarithmic equations. Kind of two properties here to review that we kind of looked at the other day with the exponential ones. These ones here, this would be the kind of what we would consider the one-to-one equation. This one here. Basically, the idea is if you have logs on both sides that have the same base, which they're going to for ours, then what they're taking logarithms of are what's going to be equal. In a sense, what I look at it as as the logs have dropped out. You'll see what I mean in a minute. And then this one would be doing the opposite to both sides. So the opposite of a logarithm would be an exponential. Okay, so something's logarithmic. To get rid of it, to do the opposite to both sides, you would raise it to a certain base. You'll see that with an example, not this first one. All right, now we're going to use that first property. To do that, we have to have the logs by themselves on both sides, and there can't be any numbers in front. So that number, if you remember our properties from before about condensing, is that goes up as a power up here. Okay. All right, so that goes as a power. So this would be log base 5 of x squared equals log base 5 of 9. So now, since both sides have a log base 5, we can set them equal to each other. X squared is 9, and then we solve, and we would get the square root of 9, but don't forget plus or minus technically, so plus or minus 3. Now, if you look over here, I have this thing that says check your answers. With logarithmic equations, sometimes we have what are called extraneous solutions, or extra solutions is another way of saying it. You've seen this before back in Algebra 2 when you solve square root equations as well. So it's kind of a similar thing. So we have to check them. Now, checking them does not mean plugging them all the way in, getting a calculator out, and seeing if both sides are equal to each other. Checking it means we don't want to be taking a logarithm of a negative. So if we think about these two solutions of x equals 3 and x equals negative 3, if I plug it back into the original, 2 log 5 of 3 equals log 5 of 9. Yeah, that's fine. That's a positive. That should be an answer. If I type this in the calculator, they will be equal. I'm not asking you to do that. I'm just looking at things. So this one's good. So then this one, though, if we look at it, 2 log base 5 of negative 3 is log base 5 of 9. That is a problem. You can't take a logarithm of a negative. There's no solution to that. If you tried to type that in a calculator, you would get non-real answer. So this one does not work. So the only answer is 3. I'm showing you this here just so you can see it, but truthfully, we just kind of do it in our heads and look at it. You'll see what I mean as we go forward. Okay? All right, so that's kind of the gist of the main type of problems, and then there's just kind of variations from there. Okay, so now a couple of these ones here would all be applying the second property, which is doing the opposite to both sides. So in this case here, we have an ln 4x equals 4. Remember, an ln is a base of e, right? This is another way of saying this would be log base e of 4x to the 4. So the opposite of a logarithm is an exponential. So I am going to take each side and raise it to that base. Okay, that's the idea. You take whatever the base is, in this case it's an e, and we raise both sides. Well, what happens here? Well, that cancels and you just get 4x, and then we get e to the 4 here. Okay, so we go to our calculator, and second, and that one, 4 gets me that. So we get 4x equals, what was that again? 54,598. And then we have to solve for x, so we divide that by 4. So 13.650. Okay. From here down, I don't think is a problem. It's that first step, okay? Now, to do this type of problem, all of these, we have to get the logarithm by itself. So I don't do it now. I don't raise both sides to an e now. The first thing I'm going to do is minus 8. 3 ln of x equals negative 6. And then now, a couple things we could do with this 3. One, we could bring it up as a power, but since this is a number here, the easiest thing to do, and it'll save us some work, is divide by 3. Okay? And so we can do like that. All right, that's the easiest thing. Now, why did I do that here, but not in the previous problem? Well, there was no logarithm over here. If there was a logarithm, I would have brought that up, this 3 up as a power. But since there is no logarithm, I just divide by 3. It makes it a lot simpler. Now, the base, again, just like over here, is an e. So this is e to the ln of x equals e to the negative 2. This cancels in a sense. X equals e to the negative 2. And we just need to get an answer for that. Second. Oops, nope, that's not the right one. And 0.135. Oh, I forgot something here. So we have to, for both of these, I kind of glanced at it quickly. We have to think about it and kind of, plug it back in. What would it look like? So ln of 0.135. Well, that's fine. That's a positive number. Same thing here. We'd plug in, well, 4 times 13.65 would be 54.598. That's fine as well. Those are positive. Basically, we just don't want to have a negative there. Okay? All right. So number 4, same thing. Now, I could bring this up as a power, but again, I'm going to have to square the 3 and square the x and then work things out there. And what's going to happen there is I'm going to have to worry about kind of extraneous solutions or extra answers. So the best thing to do is divide by 2 here. It'll save you a little work and it is easier. All right. Now, here we have a base of 5. So that means I want a base of 5 on both sides. Here and kind of cancels out. 3x equals 25. So x equals 25 over 3. We could do that as a decimal as well if you'd like. It'd be 8.3 repeated. Doesn't really matter if you want decimal or fraction in that case. And again, if I take this answer and I look at it in there, that would be fine. It would be 3 times 25 over 3, or just 25. It's a positive number. Okay, so the main idea here with these types of problems is you want to get the logarithm by itself and then raise it to whatever the base is that you're taking the logarithm of. In this case, it's a 5. Up here, these were e's. All right. Now, these ones, all right, where we got logarithms on both sides. Again, I'm reminding you here with these to check your answers. The previous ones, a lot of times, they're usually okay. If one of those answers didn't work, of course, there'd be no solution, but usually those ones work out all right. It's these other ones that sometimes we run into. All right, so here, I now have log on both sides, which this would be, remember, base 10. It's just missing. We don't write it. It's base 10. But before I can do anything here, I want to bring that up. That's different than the other ones, because if I divide by 2, it just makes it a 1/2 there. So I get log 7x minus 12 is log of x squared. Now, these are nice. You don't have to raise both sides to a certain base or anything. In a sense, it's like the logs disappear because these are both the log of base 10, and we can just drop the logs and say 7x minus 12 is x squared. All right. Now, to solve this, we got to get a 0 on one side. So we get that 7x, or x squared minus 7x plus 12. And then I have to factor. So x minus 4, x minus 3, and that would work out correctly. All right. Setting both of those equal to 0. All right, we get 4 and 3. Now, we do have to check our answers here. Now, usually I kind of do this just, in my head and looking at it, but, let's look at this one a second. So what do we get here? 7 times 4 minus 12, and on this side, 2 log of 4. Well, that's fine. Well, 7 times 4, that's 28 minus 12. So this will be log of 16. It's 2 log of 4. So that one's good. No problem there. And we're going to do the same thing here. So log 7 times 3 minus 12 equals 2 log of 3. That side's good. Here, what do we get? 21 minus 12. So that's going to be log of 9 equals 2 log of 3. That's good. And again, I'm not looking to see that, yes, this equals this. I'm just looking to make sure these numbers, when we're done plugging in, are positive. So those are both good. Okay? All right. Now, a couple things here as we move on to these last couple examples. What we want to do is get the problem to look like the previous one. Right now we have 3 logarithms, in this case ln's. What we want to do is bring them together as one, and we got to use our condensing properties. Remember, when you have 2 logarithms with an addition, that becomes multiplication. So then this becomes natural logarithm of x minus 2 times 2x minus 3. I'm going to bring this up, so that's x squared. Now, using that property, we have ln's on both sides. We can just drop the ln's. Okay, and now we have some algebra. So the algebra is going to be a little heavier on some of these. Sometimes, some good things to work through. So we have to FOIL this. Let's see, 2x squared. Outside is a negative 3x. Inside a negative 4x. So that's a negative 6x, and then the last is plus 6. Need to get a 0 on one side. We'll do it over here. Subtract x squared minus 7x plus 6. Oops, it's a 6. All right, so then you have to factor x minus 6, x minus 1. Okay. Solving those two, we get 6, and we get 1. All right, so we have to look at those two solutions and see if they work. So let's see, ln 6 minus 2 plus ln 2 times 6 minus 3 equals 2 ln of 6. By the way, you don't have to show me this work. This is not work you would have to do for the problem. This would be done in your head. I'm just showing it to you so you know where it is. So this would be ln of 4. That's good. Plus, let's see, 12 minus 3 is 9. And this side, oops, that should be an equals. And this side. So that's good. So 6 works. All right, so let's see the next one. 1 minus 2. And then 2 times 1 minus 3. And then 1. Well, the right side is fine, but the left side isn't. So this would be ln of negative 1. Right there, we're done. This is not going to work. But you can also see this one is the same thing. It is not going to work as well. All right, so as long as if you get one negative, and the reason it doesn't work is because you can't do this. And if you have one of those, it doesn't work. So the only answer is x is 6. Okay, so you are going to have times when things don't work. They may both work. They may neither one of them work. So then you would have no solution. Okay. All right. Last one. Oops, sorry about that. Last one we have to deal with here. Very similar. What we want to do first, though, is get a logarithm together in one. Now, when I say very similar, it's kind of similar to both problems we've done. It doesn't have a logarithm on this side over here on the right side. So what we have to do first is get the left side together as one logarithm. So plus is multiplication. Okay, so plus is multiplication. And now we can't just drop this logarithm. We have only 1 on this side. There's not a log base 4 of 1 on this side. So what do we have to do? Well, we've got to do the opposite, and the opposite is an exponential. So we're going to raise both sides to the base of 4. Okay, and this is the part that people are forgetting. They're going to forget this part right here. And you're going to do this, no problem. You're going to cancel those out. Get 2 minus x times x plus 3, and then you're going to say 1. But it's not 1, it's 4 on this side, and it does matter. Okay? Oh, this one's written in a strange fashion, so we got to FOIL it out. Let's see, we get 2x. Yeah, let's just do it in little steps. So 2x minus x squared plus 6 minus 3x is 4. Here's what I'm going to do. I'm going to move everything to the right. I'm going to move it that way so that we get a positive x squared. So we're going to put a 0 here. So this is x squared. This is going to be x, because 2x and negative 3x are going to give you a minus x, so add 1, and then subtract minus 2. All right, so what do we get then? The factor, x plus 2, x minus 1, 2 answers, negative 2 and 1. Now we got to check them out. Now, just because this is a negative here does not necessarily mean it doesn't work, so let's try it. Okay, so I'm going to try it up here. We're going to substitute in negative 2 first. So what do we have? Log base 4 of negative 2 plus 3 plus log base 4 of 2 minus negative 2 equals 1. All right, so what do we get here? We get log base 4 of 1 plus log base 4 of 4. So both of those are fine, so that one works. Okay, and then let's try x equals 1 and see if that works. And again, this wouldn't have to be shown in terms of writing. You can kind of do it in your head. That'd be 1 plus 3. Log base 4 of 2 minus 1. What do we get here? We get log base 4 of 4 plus log base 4 of 1. All right, so those do both work. All right, so both solutions are correct. All right, so I'm going to have you try a few of those out. I think these are probably the more complicated ones. And what makes them complicated is not so much the logarithmic stuff, it's the algebra afterwards. Remember, if you don't have logarithms on both sides, problem like this, you bring everything together as one logarithm, then you're going to have to raise it to an exponential. Okay, if we have logarithms on both sides, we want to condense it so it's one logarithm on each side with no numbers in front of the logarithms, and then you can just drop them out and do them algebraically. All right, so I have a few problems I want you to try. All right, on 221 and 222. 29 to 37, a little bit of the easier ones in terms of you're just going to need a calculator and raise it to the base. Okay, they're not the ones, all of them aren't the ones where you have logs on both sides. Okay, 85 to 104, they get a little trickier. All right, 85 to 104 are going to get a little trickier. I am going to include the solutions, so try them out. A few of the problems on those solutions I will have worked out as well, with me explaining how it works out. Okay, all right, so try them out. All right.